Hi viewers, welcome to the next section of the course, Debug and Benchmark. In this section, we'll first look at the testing strategies. Then we'll learn to catch and exceptions in child threads. After that, we will explore techniques that are used to benchmark and profile your Python applications. Let us begin with the first video of the section, Testing Strategies. In this video, we'll learn to test concurrent software systems. Then we will look at a few examples of unit testing and py-unit. One of the most important things to take away from this video course is that you need to ensure that all of your concurrent programs are tested and proven to be valid before you implement multiple threads. If you have a single-threaded application that has a bug, and you add multiple threads to that application, you now have multiple bugs, and your life becomes a hell of a lot more complex. Let's look at a few significance of testing. Instead of focusing on a metric like code coverage, you should, instead, be focusing on testing only the most important parts of your code, and then expand your tests to include your less important parts later on. In your typical project environment, trying to test everything could drastically decrease the time taken to reach the market. So, you need to try and come up with a blend of testing that does just enough to ensure platform stability while also meeting business demands. We will begin with unit tests. When it comes to writing unit tests in Python, typically the first thing that comes to the mind is the unit test module that is included by default in Python 3.6 version. py-unit is to Python what JUnit is to Java. It's the standard unit testing module that provides, basically, everything you need in order to define an automated testing strategy. Let's take an example. This is the unittest.py file. So let's open it and view the code. The first thing we need to do within our test program is to import the unit test module. This will contain everything we need in order to test our simple function. Below this import, we define our simple function, which takes in a single argument and increments it by 1. The key point here is that if other parts of our codebase start to rely on the output of this function, then we need to have some form of a checking mechanism to ensure we don't break everything if we make some changes. In the function code given next, we define our simple function test class, which inherits from unittest.testCase. Within this, we define our setup and teardown functions. These will run before and after all of the tests in our test suite. Finally, we kick off this newly defined but somewhat bare-bones test suite by calling unittest.main function. So, this is the complete code. Now save the file and execute it in the terminal. Here we will see that our setup function executes first, followed swiftly by our single test case, and finally we see our teardown function executing. It then prints out how many tests were run, how long these tests took, and finally, an overall status. So, we ran 2 tests in 0.00 seconds, and the status displayed is OK. Next is unit testing concurrent code. You will likely never be able to test every possible scenario of your codebase if you introduce multiple threads. Ideally, you should try to follow a blend of different strategies, like few displayed on the screen. The first option is unit test the parts of your code that don't run on multiple threads. Or we can create a test suite that probes your multi-threaded code in a variety of different ways. If possible, try and include load tests on these specific sections of code to give you confidence that your multi-threaded logic stands up to constant pressure. The final topic is integration tests. Integration tests are used to ensure the correctness of multiple sections of code or different parts of your systems. Like your unit tests, integration tests give you that extra bit of insight to see how your system will run when synced up with everything else. In this video, we have learned few testing strategies,